Hello everyone, welcome to lesson 36 of our GoLang course. In this lesson, we will continue our journey of functions in Go. We are going to cover closures. So let's begin. A closure is a special type of a function in Go that closes over or captures the variable from its surrounding environment. In other words, the lexical scope. Closure captures the variable from the environment in which they are created. This environment is typically a function, but it could be any code block. The closure keeps a reference to these captured variables. Even after the surrounding function or the block has finished execution, the variable that the closure closes over has gone out of scope. The closure still retains access to the captured variable. This is because the closure remembers the scope in which it was created. Closures effectively allow functions to have an associated state. This is because they can access and modify the variable that they have captured. Each time the closure is called, it can operate on and potentially change the state of those variables. Let's look at some benefits of a closure. Closures have a unique ability to access and manipulate variables from their surrounding environment, even if those variables are not explicitly passed an argument to the closure. We will see this with an example next. Another thing to remember is that closures maintain independent copies of the variable they have captured. This means that multiple closures created from the same enclosing scope will have their own set of captured variables. Therefore, each closure can operate on its own set of captured variables independent of other closures. Closures are a powerful feature in Go and are widely used in various programming patterns. Some common uses are memoization functions. Closures can be used to create functions that cache and reuse the previous computed result. This can greatly improve the efficiency of the function that performs expensive computations. Closures are often used to implement callback functions as well, where a function is passed as an argument to another function and is executed later when a certain condition is met. Here we have an example of closure. So you see, first, here we define message, a variable that the closure will later on capture. Next, we define an anonymous function, greet, which takes a name string and prints the name string with the message. You can see here the message is captured from the surrounding function scope. That is, we never pass the message string as a function argument, but since it's a closure or inside another function, we were able to capture the message string. Next, since greet now holds a function, we can call greet with two values. First we call it with ls, then we call it with bob. If you run the program, you will get hello ls and hello bob printed to the console. This is again because we were able to capture the message variable from the surrounding scope. Let us now look at an code example for closures. Here, first I created a counter function which returns another function. The function that we return is a closure. Inside the counter function, I created a variable count with a value of 0. And inside the function that we return, which is a closure, we capture the count variable. We increase the value by 1 and then return count. So let us now see what happens when we work with this closure. Here, I have created an increment variable that will hold the closure that we return from the counter function. First, I am going to do fmt println, and inside it, I am going to call the increment function. I am also going to create a copy of it. So, what do you expect the values to be? Let us run our program and see what the output is, and then we will go over how we got to that. As you can see, the first value that was printed to the console is 1, but the next value is 2. How did that happen? That is because the closure that returned from the counter function was able to capture the count value. First time we call increment, we get return 1, which is right. Since closure can maintain a state of the variables that they capture, count now is 1. So the next time you call it, here the value is 1. When we execute count 1, it becomes 2. As such, in the second println statement, we get 2. If I do another print statement and run our program, you will see it prints 1, 2, 3. This is again because it was able to capture and maintain its own state. This is an important feature that is used in memoization functions or algorithms. Another benefit of closure is, usually in a production application, when we are going to call a function, which is like a callback, we can pass a closure instead. If I have a logger, I can capture this value here and log the information or log the count value when it's running, even though the function we defined here is not accepting any value. Let's now look at anonymous functions. We have already used anonymous functions in our code examples, but we haven't explicitly gone over them. Anonymous functions, also known as function literals or lambda functions in programming, are functions that are defined without a name. They are declared in line without specific identifier. Anonymous functions are handy when you need to define a function for a specific task, but it doesn't need to be reused everywhere in your code. They allow you to create a function on the fly without the need of assigning it a name or declaring it separately. Anonymous functions are commonly used to define callback functions, which are functions passed as an argument to other functions. The receiving function can then call the function or the callback function at an appropriate time. This is a powerful tool for customizing behavior. Here in the example, you can see I define an anonymous function without a name. Inside it, I'm doing just a println statement. If you notice, I have parentheses right after the anonymous function declaration, which means I'm calling it right away. Here, I have another example of anonymous function, which takes message string and does a println. So again, I am calling it on the same line, passing hello. You will see when this program runs, message hello printed to the console. Let's now see some more examples of anonymous functions. Here, as you can see, number is an int slice which holds value 1, 2, 3, 4, 5. Next, I am going to create a slice operation function which accepts a slice of value and then a operation function. As you can see, I defined a slice operation function which takes a slice of int values and then an operation function. Inside it, we create another slice result which will hold the result of performing operation on each value in the slice. Then we range over the slice that we were provided, saving the values at index I by performing the operation on the past value or the value saved at that index. In the end, we are returning a result. So in the main function, I'm going to call the slice operation function. Let's see how we do it. Here, I call the slice operation function passing the number slice and then passing a callback, which is also an anonymous function. Here, the anonymous function just returns the square value of the input value. When we do this operation, we get numbers. On each value, this function will be called, and then all these values are saved in result, which is then returned to our main block, where we save it in the squared slice. Now let's run our program to see the output. As you can see, each value of a slice was squared indeed. So this is another use of anonymous and callback functions. You can see how modular it is. You can pass any function here and that operation will be performed on the slice values. Let's now summarize whatever we have learned in this lesson. We learned a closure is a special type of a function in Go that captures or closes over variables from its surrounding environment. This means it can access and use those variables even after the surrounding scope has finished execution. Closures effectively allow functions to have an associated state. They can capture and manipulate variables, and each closure maintains its own set of captured values. This means multiple closures created from the same enclosing scope will have their own unique set of captured values. Next, we looked at anonymous functions, also known as function literals or lambdas. These are the functions that are defined without a specific identifier. They can be created on the fly and used where they are defined. Both closures and anonymous functions are powerful tools that provide the flexibility in how you structure and design your code. They allow you to define behavior in a localized and context-specific manner. This can lead to code that is modular, expressive, and adaptable to different situations. That's it for the lesson. I hope you enjoyed it. If you have any questions, please feel free to leave a comment under the video or reach out to our Discord server. I will see you in the next lesson. Happy coding!